My dear 10th class students, our chapter is coordinate geometry and we are solving the last question of this chapter. So this is question number 5, exercise 7.3. Question is, you have studied in class 9th that a median of a triangle divides it into two triangles of equal areas. Verify this result for triangle ABC, whose vertices are A4 minus 6, B3 minus 2, and C5 and 2. So you have already know that a median divides a triangle into two triangles of equal in area. So we have to prove this. We have to verify this in this triangle whose three vertices are given. Let us consider a triangle ABC. So ABC is a triangle with let the vertices of triangle ABC are A4 minus 6, B3 minus 2, and C5 2, and AD be its median. So let AD be its median. So we know that a median is drawn from a vertex, from any vertex to a triangle to its opposite side. This bisects the opposite side. Let AD be the median of this side BC, then BD is equal DC. So here we first we find the coordinates of this D. When we find the coordinates of this D, then we get also the three vertices of this triangle and this triangle. Then we find the area of these two triangles separately, and we see that if the areas are this same or not. When the areas of two triangles are same, then we verify this question, that is a median divides a triangle into two triangles of equal in areas. So first we find the coordinates of D. So D is the midpoint of this. D is the midpoint of BC. Then coordinates of BD are, then coordinates of D is equal. That is x2 plus x1, or x1 plus x2, x2 plus x1, or x1 plus x2 divided by 2, or y2 plus y1 divided by 2. So we know when we find the coordinates of a midpoint, so we're using this formula. So here this is x1 y1 and this x2 y2. So this is then 5, this is x1, this is x1 y1, this is x2 y2, this x2 is 5 and x1 is 3. So 5 plus 3 divided by 2. Then this is this y2 is 2, this is minus 2, this y1 divided by 2. So we get here, then this is 8 divided by 4 and 0 divided by 2. So this gives 4 2s are 8, 4 sorry, this is 2, 2 4s are 8, and this is 0. So the coordinates of this point, that is this D, that is 4 and 0. Now we find the area of this first triangle, that is ABD and ADC. So area of first triangle ABD is equal here. So the triangle, this is triangle ABD. So we're using the formula here. When we find the area of a triangle, we're using the formula, that is half of, this is x1 into y2 minus y3 plus x2 into y3 minus y1 plus x2 into y1 minus y2. So we give the value here. This is x1 y1, let this x1 y1, this is x2 y2, and this is x3 y3. So here x1 is equal here 4, then y1 is equal minus 6, x2 is equal 3, and y2 is equal, that is minus 2, and x3 is equal, x3 is 4, and y3 is equal 0. So we give the value in place of x1 y1 x1 x2 and x3, and y2 and y1 y2 and y3. We give these values and we get this, that is minus 3 units. This is the area of the triangle by using this formula. So this is triangle ABD. Similarly, so this is minus 3, but area cannot be in negative. Area must be positive. So area of triangle is then 3 square unit. So this is first. Then similarly we find the area of this triangle, that is this. So its area is 3 square unit, 3 square units. So this is area of this triangle ABD. then we find the area of this triangle, that is ADC. So we're using the same formula, that is half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Here x1 is this, and x1 is 4, y1 is minus 6, x2 is here, that is 4, and y2 is 0, x3 is, that is 5, and y3 is, this is 2. So give the value of these x1, x2, x3 and y1, y2 and y3 in this formula. So we get also minus 3, but area cannot be negative, so this is also 3 square units. So its area is also 3 square unit. Area is 3 square units. So from first and second, this is first, this is first, and this is first, and this is second. So from first and second, areas are same. Area of triangle ABD is equal area of triangle ADC. Hence median divides a triangle into two triangles of equal in area. So this ends this